still don't get this and I still have that exam tomorrow. Chex! Play Chex!
Hey, Macky, what's up?
I'm getting really stressed and I still have this exam tomorrow.
Maybe I can help. What is it about?
It's about relative extrema.
Oh yeah, it is confusing at first, but it's simple. I can help you with that.
Alright, thanks.
So, okay, let's start from the beginning.
The beginning? Why? I already know that.
I mean, let's start from defining some important stuff before answering the questions.
But I already know that.
Yeah, I know, but it's better to make sure that you understand all of them.
But I do understand them.
Okay, fine. So just treat it as a review for your exam tomorrow, okay?
Okay, sounds like a good idea.
Okay, first, let me explain with a graph. Like here.
Oh,
So a function is said to be increasing when the graph rises as it goes from left to right. On the other hand, a function is decreasing when the graph falls and it goes from left to right also.
that's obvious. Everyone knows that.
Yes, okay, I know. We're just reviewing things, okay?
Fine.
So as I was saying, also the increasing-decreasing concept can be explained through the slope of the tangent lines to the curve, like this one. So observe that the slope of the tangent line to the curve is positive when the curve is rising and negative when it is falling. And in order for you to get the slope of the tangent line, you use derivatives. I assume you know how to derive functions, right?
Yeah, don't worry. I perfectly know how to derive functions.
Cool, so this won't be too hard for you. Okay, so if there are no graphs visually to see if curves are increasing, decreasing, you use derivatives.
Since f prime of x represents the slope, we can infer the following. If f prime of x is greater than 0 for all x in an interval, then the function is increasing in that interval. If f prime of x is less than 0 for all x in an interval, then the function is decreasing in that interval. Yeah, so I know it's that easy. If the first derivative is greater than 0, then it's increasing. And if it's less than 0, then it's decreasing.
Cool, so let's proceed to the extreme values of the function.
Okay, this is the part where I start to get confused.
Okay, so consider this graph. F of x below is in a closed interval a, b.
What do you mean by closed interval?
It means that it does not go into infinity or the line is only limited to this graph. Points a, b, c, and d are critical points of a function. The point A is a relative maximum point, while B is a relative minimum point of the function. These points are relatively higher or lower than all other points nearby. C and D are absolute extreme points of the graph. Since C is the highest and D is the lowest point on this graph, C is the absolute maximum point and D is the absolute minimum point of the function. Now, observe that the relative extrema, maximum and minimum, are attained only at points where the tangent line is horizontal. That is, where the slope of the tangent line is 0. And those points where the slope of the tangent line is 0 are called the critical points. In other cases, relative extrema can be found where the tangent line is vertical. That is, where the slope of the tangent line is undefined. It follows that, at relative extreme point, either the derivative is 0 or it does not exist.
Okay, so let's try this function here. We'll derive. Then we equate this to 0. Simplify this way. Let's take out 3. Divided by 3. The other side is divided by 3. And then that leaves us with... Right, x minus 1, x minus 3. We have x equals 1 and x equals 3.
Now, after finding the critical values, we have to determine the exact nature of that critical points, if it's relative maximum or relative minimum.
Why? Why do we have to know?
Idea of how the curves might look like with those critical values.
Oh, okay, I get it. That's when we use the first derivative test for relative extrema. Okay, so first derivative test. Let a be a critical value of f. If f prime of x changes from positive to negative at a, then f of x has a relative minimum at a. If f prime of x changes from negative to positive at a, then f of x has a relative minimum at a. If f prime of x does not change sign at a, then f of x has no relative extremum at a. Okay.
I think it's better to explain with example. Determine all relative extreme points of the function f of x equals to x cubed minus 3x squared plus 1. Just like how you answered the previous example, get the first derivation of f of x and equate it to 0 to get the critical values. We get x equals 0 and x equals 2. For the first derivative test, think of two nearest numbers, or left and right nearby points to the critical values obtained. So for x equals 0, its left and right nearby points are negative 1 and 1. We then substitute these nearby numbers to f prime of x. We get positive 9 on the left and negative 3 on the right. As you can see, the change is from positive to negative. It means the function at x equals 0 has a relative maximum. The same is done for x equals 2. Its nearby numbers are 1 on its left and 3 on its right. Then substitute them to f prime of x. We get negative 3 on the left and positive 9 on the right, in which the change is from negative to positive. This means that the function at x equals 2 has a relative minimum. Then get values of y by solving for f of 0 and f of 2 to obtain the actual points. We can now see how a graph of a function looks like.
I get it now. But it's so long. Why do we first have to think of two closest numbers to the critical values and substitute all the values of them to f of x just to determine their nature?
I know, right? But there's another way to classify the critical points as relative maximum or minimum.
Cool, so why didn't you say so? I mean, wait, isn't that the purpose of the second derivative test?
Yep, second derivative test it is. Here are the guidelines.
So the second derivative test. Let a be a critical value of f. If f double prime of a is greater than 0, f of a is a relative minimum. If f double prime of a is less than 0, f of a is a relative maximum. If f double prime of a is 0 or equal to 0, or f of double prime of a does not exist, then the test is inconclusive. So that's when we use the first derivative test again. Okay, so it's just the opposite. If it's greater than 0, it's minimum. Then if it's less than 0, it's maximum. That's what makes it so confusing. But then, at least I get it now. And if the second derivative is equal to 0 or it doesn't exist, that's when we use the first derivative test, right?
Yeah, easy, right? So let's try solving. After substitutions to the second derivative function, we get negative 6 that is less than 0, which means there is a relative maximum at x equals 0. And we get positive 6 that is greater than 0, which means there is a relative minimum at x equals to 1.
Alright, I guess I'm ready for my exam tomorrow.
See, I told you it's simple.
Alright, it's quattro time!